Hi everyone, welcome back, and today we are going to see about the speed control of induction motor on stator side. So normally in a DC machine, the DC shunt motor is known as constant speed motor, and in AC machine the induction motor is also known as constant speed motor. This is because the speed is varying from the no load to full load, but the ratio between the no load to full load, the speed variation is considerably very small. So that's why it is called almost constant. That is called a constant speed motor. So for that particular applications, we can use this kind of induction motor and DC shunt motor where we are requiring almost constant speed. So for the speed control of induction motor, so normally we are prepared in two sides. One is called stator side control and another one is rotor side control. So in stator side control, there are four methods are available. One is stator voltage control and stator frequency control, stator voltage bar frequency control, then pole changing method. And in the rotor side, adding external resistance in the rotor circuit, cascade control and slip power recovery schemes. So these are used in the induction machines. And for the stator side, the induction motor speed control from stator side. So the first one, by changing the applied voltage, or it may be called as stator voltage control. So according to the torque equation of induction machine, here the torque which is equal to K1 into S into E2 square into R2 divided by root of R2 square plus S into X2 whole square. So here K is nothing but constant, so we can neglect that, and R2 is nothing but rotor resistance, that too constant here, so we can eliminate that. And the X into X2, here the slip is very small, so that yes, slip into X2, S into X2 is also very small, so that we can also neglect that. So after neglecting all the constant and the two small values, so finally we are getting the torque is directly proportional to slip into E2 square, slip into E2 square. Okay. So the E2 is nothing but rotor induced EMF. So here the rotor induced EMF, it is depends on the supply voltage. So the E2 is directly proportional to V. So instead of E2, we can substitute as V. So the torque is directly proportional to S into V square. So if you are changing the applied voltage, the torque is getting changes. So if the torque changes, the speed will changes. So hence, by providing the load torque, here the slip increases. With respect to the slip increases with the decrease in voltage, and consequently the speed is also decreases. So by changing the supply voltage or apply voltage of induction machine, the torque can be variable, so that the speed also can be variable. And the second one, by changing the applied frequency, or it may be called as stator frequency control. So according to the speed equation of induction machine, the speed equation, that is nothing but synchronous speed NS is equal to 120 F by P. So F is nothing but supply frequency is 50 Hz and the number of poles, it is depends on the machine. It may be either 4 pole, 6 pole, or it may be 8 pole machine, whatever it may be. So from this, from the slip equation, we can able to determine the actual speed or the rotor speed of induction motor N, which is equal to Ns of 1 minus S. So here Ns is nothing but synchronous speed, and 1 minus S, and S is nothing but N slip value. It is the difference between the speed of synchronous speed and the actual speed. So here, if the frequency is changeable and the synchronous speed is also getting changes. Okay, so if the frequency, you can see Ns is equal to 120 F. F is nothing but proportional. If the frequency is increases, the synchronous speed will increase. If the frequency is decreases, the synchronous speed will decrease. And if the synchronous speed is decreases, automatically the actual speed will get variable, because the actual speed which is depends on ns of 1 minus s. So if the synchronous speed is changeable, automatically the actual speed is also getting changeable. And the next one, constant V by F control, voltage bar frequency control. So here the air gap formula of an induction machine, pi g is equal to 1 divided by 4.44 K1 T phase into V by F. So here 4.44 is constant, K1 is also constant, and T phase, the T phase is nothing but the number of turns per winding is also constant. So all the constants can be eliminated, it can be neglected. So after neglecting, only we are getting the air gap flux pi g is equal to V by F. So the voltage is variable and the frequency is variable. So here in an induction machine, it has the small air gap. So if the air gap is getting variable, so it may reach the saturation level. So in order to avoid the saturation level, so the air gap has to be maintained as always constant. So based on the maintenance of air gap, so correspondingly, for example, if the voltage is 10 and the frequency is 5, so 10 by 5 we are getting the air gap flux is 2. Suppose if I want to increase the voltage from 10 to 20 and the frequency is also increased from 5 to 10. So 20 divided by 10, 20 divided by 10, so we are getting same 2. Suppose if the voltage is 100, the frequency should be 50. So that 100 by 50 we are getting same 2. So correspondingly, with the main objective, we have to maintain the air gap flux as constant. Otherwise it may reach the saturation level, so it unable to change anything. So with the maintaining of the air gap flux, the voltage and the frequency has to be changed accordingly. So by varying the voltage and frequency, we can able to vary the speed of the induction machine. And the next one, changing stator poles. Just you can see here, in a synchronous speed, NS is equal to 120 F by P. If the number of poles is 4, the speed is 1500 RPM, and if the number of poles is 6, the speed is 1000 RPM. So if the number of poles is getting variable, the speed is getting changes. So here this is the schematic diagram of the pole changing method. So it is the automation. With the help of switching device, we can able to switch on whether it's 4 pole or 6 pole. So based on that, we can able to switch on. So this is an assessment. Now you know what is slip. Now you know what is slip, because if the slip is variable, the actual speed is getting changing. So we can be able to control the actual speed by changing slip. So may know what is the meaning of slip. So can put your answer in the comment section. Thank you. And these are the few references. Thank you.